Good morning, everybody. My name is Dr. Travis Van Leeuwen. I'm a research associate here at the Cape Eleuthera Institute. My lab group works on many different species. One of those species is the lionfish, the invasive lionfish. In previous years, CI and the Island School have worked together to sort of study lionfish over the last 8 years. And what they've done is they've identified sort of the movement of lionfish on our local patch reefs. They've looked at lionfish behavior and diet specificity in these invasive species. This semester, we took kind of a novel approach to this and really had the chance to really use novel technology, no bigger than a pill, to study and try and get uninhibited feeding rates of these invasive species. In the next presentation after this one, we've also started looking at the spread of lionfish into habitats that aren't traditionally associated with lionfish. So really quite cool and novel research going on here, really in its early stages, but we're still working towards it.
Hi everyone, my name is Jody Ball. I am a research technician on the Reef Ecology and Restoration Program at Cape Eleuthera Institute. It's been a real privilege working with the Spring 2017 Lionfish Physiology class.
Hi everybody, we're Team Lionfish Physiology. I'm Hayden Stein.
I'm Abigail Wright. I'm Catherine Casa.
I'm Layla Lemon. I'm Natalie Edmond.
I'm Martina Capilano.
And I'm X Prince.
At the heart of the invasion, exploring the use of heart rate loggers as a proxy for feeding rates in lionfish in their unnatural habitat. So can we get a show of hands in here of how many people have seen a lionfish on our reefs? All right, so a lot of us here. Well, did you guys know that lionfish aren't actually native to our reefs?
Lionfish are actually native to the Indo-Pacific range. Their invasion first started off the coast of Florida with their first formal documentation in 1984. And lionfish spread to the Bahamas with their first formal documentation in 2004. This visual shows the rapid spread of lionfish invasion, and although the visual stops in 2013, lionfish are continuing to spread and have even been seen off the coast of Brazil. Lionfish are able to spread so quickly because they have no natural predators, and they can inhabit a wide range of environments, such as seagrass beds, mangroves, and coral reefs. Because of the lionfish's rapid population increase, they have a 5 times higher density in the Bahamas compared to their native range. Affected areas with lionfish have many possible repercussions. Lionfish are voracious predators who have been known to feed upon over 42 different species of fish. Many of these species are economically and ecologically important, such as grouper and parrotfish. Lionfish diets are detrimental to coral reefs because they feed upon all of the reef-maintaining fish, so the coral reefs don't have any fish to help them grow. The coral reefs are essential to the Bahamian tourism market because scuba divers and snorkelers come from around the world to see the beautiful reefs, and without these, the market may fall. Lionfish are also detrimental to the fisheries market because they feed upon all of the economically important fish, and the fisheries cannot collect enough biomass.
Since the lionfish invasion in the Bahamas, there have been multiple studies about them. And since the invasion, we've been able to ascertain that lionfish are crepuscular feeders, meaning that they feed primarily during dawn and dusk. And during these times of feeding, lionfish have an 85% success rate because their prey do not recognize them as predators. And although these studies provided extremely valuable information, there were some limitations because they were all completed via scuba divers, and the scuba divers could have been affecting lionfish behavior and then feeding rates as well. And also, as you can see from the visual above, there is a lionfish on this reef, and they're very hard to track, and therefore feeding them would also be difficult to track as well. So we would like to find a more accurate feeding rate in lionfish. Some of our other objectives for this study are to find an accurate acclimation time for lionfish, and then use heart rate as a proxy for feeding rates in lionfish. So an accurate acclimation time is from when we bring lionfish on the reefs into the lab and then perform various stresses on them. And then our heart rate loggers look like this. They're really small, and they're data storage devices. So we implant these into lionfish, and then they are pre-programmed to begin recording after our estimated acclimation time. And then after they begin recording, they have a brief recording period, usually about 48 hours. And then after the recording period is over, we have to go back and collect these loggers from the lionfish and take them out and then analyze the data on a computer.
So in order to perform our study, we first go on to patch reefs around the Cape of Eleuthera and collect lionfish using these plastic bags, as you see here. We then bring them back on the boat and transport them to the lab here at CEI. We then measure their acclimation period. So we do this by feeding the fish every day for 5 minutes, and once a fish has eaten for 3 days consecutively, we consider them acclimated. So we try to find an approximation for the acclimation time it takes for a lionfish after being introduced to the lab, to an anesthetic that we give them, and to a surgery performed. Once we have an estimation on how many days total that would be, we then bring our study out into open waters. So then we use the same method in catching the lionfish, and here you can see us giving them an anesthetic. We then tag them on the boat using an external tag and release them back onto the patch reefs. So we do this to see whether the lionfish will stay on the same reef or not, because these loggers are expensive and only record data for about 24 to 48 hours. So it's important that we're able to retrieve them. So before actually implanting them, we just need to make sure that the lionfish are in fact staying on the reefs.
Okay, our first figure in our results section shows the amount of time it takes the fish to eat after the 3 different procedures that we perform on the fish. So on the y-axis, you can see the amount of time it takes them to feed in minutes, and then on the x-axis, we have the 3 different procedure types that we perform, which were the lab acclimation, the anesthetic, and the implantation of the heart rate loggers. So as you can see, the lab acclimation, it took the fish about 8 days or a little bit over 10,000 minutes to start feeding. And the reason why we have this unit in minutes is because it only took the fish a few minutes to start feeding after both the anesthetic and the implantation, and we needed a baseline unit in order to be able to compare all 3 procedures on the same graph. And the reason that this is so important is because we need to know their average acclimation time in order to be able to pre-program the loggers to turn on for when the fish will start feeding. Our second results section shows the correlation between the mass of the fish and the time it takes that fish to feed within the 3 different procedure types. So as you can see, the solid black diagonal line is representative of the lab acclimation procedure. And since this line is sloping upward, we can conclude that there's a positive correlation between the mass of the fish and the time it takes that fish to feed. So what this means is that the bigger the fish is, the longer it's going to take that fish to feed after we move it into our lab. And the other 2 lines represent the anesthetic and the implantation, and we see no correlation between the mass of the fish and the time it took those fish to feed after those 2 procedures.
This is an ECG which shows the actual heart rate from a lionfish. We were able to get this data once we removed the logger from the lionfish, and although you can see many peaks and dips in the data, we were unable to determine whether this was because of feeding or because of a slip of the logger in the body cavity of the lionfish. However, in the future, we hope to determine a better way to analyze this data. So through our data, we figured out that the lab acclimation is the limiting factor, and this was because of the stress we put the lionfish through once we took them off the patch reefs and transferred them into the tanks at the wet labs. And we also determined that the bigger the fish is, the older it is, and that bigger fish take longer to acclimate. This is extremely important in our study because we have to pre-program the loggers, as we said, and they can only take data for a certain period of time. So to make sure we set the loggers at the appropriate time, we need to understand this. And so, for example, bigger lionfish will set their logger to turn on at a longer date than smaller lionfish.
So the heart rate loggers that we're using is a novel technology in the lionfish that's never been done before. So So it's really hard to interpret, and so we've concluded that the data is inconclusive at this time. We've also found that the recapture rates in the lionfish, in the loggers, is very low, and so more data is needed before we can widely implement them. So for future studies, we hope to figure out a way to consistently recapture the lionfish off the reefs because we found that it's hard to find them again after we put them on the reefs, and with the loggers being very expensive, I mean, it's pretty important to be able to get the lionfish back off the reefs. And we hope to actually start putting these lionfish back out on the reefs with the loggers in them after the lab work. We'd like to thank all the people listed, but specifically Travis Van Leeuwen and Jody Ball. And this is our literature cited. Thank you. Are there any questions?
So as a way to decrease that population, do you have any idea whether this could be made into a popular sushi item?
Sorry, can you repeat the question?
As a way to decrease the population of lionfish, do you have any idea whether this could be made into a popular edible sushi item?
So the question was, as a way to decrease the population, I believe, increase the demand for markets to serve lionfish.
I mean, is it edible?
Yeah, actually, it's only venomous. It's not poisonous, so you have to. So I mean, it's really good, actually, but.
Yeah, so lionfish are actually really good to eat, and we have been trying to get fishermen to start catching more of them to feed, and they're like a really good fish. This particular experiment is not exactly looking for a solution to the lionfish problem because in the near future we don't foresee a solution since they have spread so rapidly. However, we are looking more to see their effects on the reef so we can analyze that before figuring out how to solve the problem. We really need to know like how big the problem is right now. Yes.
In areas where they've been established longer, like in Florida since the 80s, do they become recognized as predators, or is that a persistent problem?
Okay, so the question is, in areas that they've been for longer, do they become recognizable as predators to their prey? Okay, so the answer to the question is no, not that we know of. Studies have been done. We don't exactly know how the lionfish are doing this, but the prey are never able, in their invasive areas, the prey are never able to recognize them as predators, and that's why they have such a high success rate when hunting. And like even in Florida, places they've been established for longer, it's never been able to happen. Yes.
What is their native habitat and who eats them there?
The question is, what is their native habitat and who eats them there?
So the lionfish's native habitat, or their native range, is in the Indo-Pacific Oceans, but their habitat, I believe, is coral reefs and seagrass beds as well, like similar to here. Their predators, we did not focus on their native range, but here at least, they don't have any natural predators. Divers have tried feeding lionfish to sharks so that sharks will start eating them here, but that is actually really dangerous, and we're trying to prevent that.
What's the quality of the coral reefs in their natural habitat?
So the question was, what's the quality of the coral reefs in their natural habitat?
So there haven't really been any known. They have natural predators there, so there's no negative effects on the reefs there because obviously they have animals eating them every day. But on these coral reefs here, there's no natural predators, so they'll eat all the juvenile fish, and then the next generation of fish won't be there to help the coral reefs out. Any more questions?